Today, we're going to be taking a deep dive into Kim Sterelny's book, The Evolved Apprentice, How Evolution Made Humans Unique.
This book, it was published in 2012, and it really grapples with this fundamental question, what sets human cognition and our social lives apart from our nearest primate relatives? And of course, it looks at this through an evolutionary lens.
And from what I've read, Sterelny seems to emphasize learning, especially how knowledge builds up over generations. Kind of a different take than those evolutionary psychology folks who are all about innate modules, right?
That's a good observation. The book really zeroes in on this idea that what makes humans unique is this coevolutionary dance between cultural inheritance and something called niche construction.
Coevolution. Okay, so first things first. What exactly does Sterelny mean by this cultural inheritance thing? And is it that different from what we see in other animals?
So Sterling defines cultural inheritance as this kind of cross-generational buildup of information. And a big part of his argument is that there's this major difference between, say, hominins and chimpanzees, how they inherit culture and the extent of it. Chimps, they do some social learning, sure, but the mechanisms and the scope are just not the same as what we see in the hominin lineage.
I see. So chimpanzees, they learn from each other. We know that. But what's the key difference in how hominins inherit culture that Sterelny highlights?
For hominins, it's all about signaling and tapping into what Sterling calls latent information. Think of it like you know how to pick the safe berries because you've seen others eat them and not get sick. That information's there in their actions, embedded in the environment, and that's what allows for this much richer and more cumulative transmission of knowledge that you just don't see in other primates.
Got it. Now on to this niche construction piece. How does Sterelny define that, and how does it fit into this whole human uniqueness puzzle?
Niche construction is basically the way hominins actively change their environment, and importantly, the environment for future generations too. Chimps. Their world mostly changes because of outside forces, right? Ecological pressures and such. But hominins, we take action, we use technologies, and we actually modify our surroundings, and these changes, they have this lasting impact on the selective pressures that act on us, and get this, our descendants.
It's like our actions change the world, and those changes then come back around and shape our evolution and our future actions. Is that what he means by a feedback loop?
Exactly. And Sterling's big point is that human evolution makes more sense when you look at it through these positive feedback loops. Not just one aha moment or one key innovation. He's talking about lots of cognitive, behavioral, social capacities all feeding into each other. And this process of niche construction, when coupled with cultural inheritance,
Yeah.
can actually accelerate evolutionary change. And one of the things that Sterling points to as an example of this is the emergence of what we call behavioral modernity in the archaeological record. So around 50,000 years ago, we see this explosion of tools, art, symbolic behavior.
Right, the Upper Paleolithic Revolution, as some people call it.
Exactly. And Sterney argues that this wasn't necessarily a sudden leap in brain power.
Right.
It was more of a culmination of generations of cultural learning and niche construction, gradually shaping both our minds and our environment.
I'm with you. Now, he specifically talks about a couple of these feedback loops, right? Let's start with the one that connects expertise, social learning, and life history. How do those pieces fit together?
Okay, so social learning. What's really cool here is how it allows us to pass down what Sterling calls long shelf life information across generations. This knowledge building, well, it both depends on and supports these extended childhoods, adolescence, and even longer lifespans. And these life history changes, they're tied to things like ecological innovation and cooperative foraging. Sterling even uses the phrase deep education because becoming technologically competent, it takes time.
So the more we depend on complex skills being passed down, the longer we need to learn them, which in turn changes our whole development and lifespan.
Right. For instance, imagine learning complex foraging techniques. They allowed for better resource gathering, which could support individuals through longer developmental phases. So it creates this cycle, right? Better social learning helps us live longer, become more expert, which then makes social learning even more valuable. The point is, human intelligence didn't just pop up, it built on itself over and over through this self-reinforcing loop of learning and increasing societal complexity.
Fascinating. Okay, and what about that second feedback loop, the one between expertise and individual adaptations for social learning? How does that one work?
While as our traditions become more and more loaded with information, there's this pressure to get better at learning from others to keep up. Individuals who are better at learning in these complex cultural environments, they'd have an advantage, right? And this is what leads to Sterelny's apprentice learning model.
So, in a nutshell, what's Sterelny's main point about human uniqueness in the Evolved Apprentice? What's the big takeaway he wants to leave us with?
He's basically arguing that what makes us unique isn't just like pre-programmed cognitive stuff, not primarily anyway.
Okay, interesting.
It's more about this like co-evolutionary process, so sophisticated learning mechanisms, the ones we're born with. Combined with that, get this, the way we build our social and informational environments, specifically to make social learning super efficient across generations. It's like we've created this system where knowledge just builds and builds. His real emphasis is that our cognitive abilities are kind of a collective achievement.
So it's not just about what's in our heads, it's about the knowledge we've inherited and built upon as a species.
And this is where it gets different from, say, a lot of mainstream evolutionary psychology.
Okay, how so?
Well, they often focus on, mapping the end state of cognitive adaptations, like what's the final product of evolution. But Sterling is more interested in the journey, how we got here, this continuous back and forth between learning and the world we've created to make learning even better.
I see. So the environment isn't just a setting, it's like shaping our brains over time.
Absolutely. Now, Sterling also talks about this thing called the challenge of novelty.
Okay, the challenge of novelty. What's that about?
He's saying that to understand human evolution, we've got to think about how good we are at dealing with new problems, unforeseen stuff. And the thing is, hominin environments, they've been really unstable, not just physically, but biologically and super importantly, socially. Our ancestors didn't face like one static set of problems.
Can you give me an example of how this social instability thing plays out in our behavior?
Imagine different cultures reacting to an insult. So there's this idea of cultures of honor, right? Nisbet and Cohen talk about this. In those cultures, you're expected to be aggressive, retaliate to maintain your standing.
Yeah.
But then say you look at the Faroe Islands, totally different. They value social harmony. So they're more likely to, try and resolve the conflict peacefully. These different environments, they shape how people behave, maybe even how they feel and their motivations. It's not like we're all hardwired to react the same way. Culture matters.
So our behavior is flexible. It depends on where we are and what our culture teaches us, basically.
Exactly. And Sterelny, he also rejects this idea of a single magic moment in human evolution.
Okay, what do you mean? Like there wasn't one thing that suddenly made us human?
Right. He's saying it wasn't just like, bam, language appears or tool use gets super complex and that's it. It's more about these positive feedback loops.
Gotcha.
Coevolution, our cognitive abilities, how we behave, our social structures, all these things developing together, reinforcing each other.
So a bunch of gradual changes across a lot of areas.
Yeah. So think about social foraging, learning how to find food from others.
Makes sense.
This leads to information building up across generations.
Right.
And that allows for more specialization and division of labor. People can get really good at specific tasks, making the whole group more efficient.
And how does this tie into how long we live and how we grow up, our life history?
Well, learning complex skills takes time, right? Think about making advanced tools or learning super specific hunting strategies. You need a long childhood to really master that stuff.
Right.
So selection favors that. Longer childhoods, adolescence, even a longer lifespan overall. Adults need time to learn, and then they need time to pass that knowledge on. It's fascinating, Sterling points out, that in a lot of forager societies, people are best at getting food around age 30. That's like peak foraging age. Shows you how much learning goes into it.
Wow. That really highlights how much we invest in learning as humans. Okay, the second feedback loop is about expertise and the ways we're adapted for social learning.
Right.
Yeah. This one's about how we build up this cognitive capital, all the knowledge and skills in a culture. And it happens through cultural learning.
Okay, so when someone figures something out, it becomes part of the group's knowledge, and then future generations can learn it too.
Right. It's like this ratchet effect. Culture builds on itself over time. He uses this cool example of Japanese macaques washing potatoes.
Oh, yeah, I've heard about that. How does that fit in?
So one macaque figures out, hey, if I wash this sweet potato in the sea, it tastes better.
Right.
Pure chance.
But then other macaques see this and start doing it too. It creates this new learning opportunity. Pretty simple, but it shows how one individual can change the learning landscape for a whole group.
Okay, and he compares this to chimps, right? What's the difference there?
So chimps are smart, they learn socially, they even come up with new stuff, but it doesn't seem to stick in the same way. They might invent a cool way to get termites, but it doesn't lead to, like, generations of innovation building on that technique. It doesn't become a defining trait of that chimp group. They don't have that same cumulative effect.
It's not just about individuals learning. It's about those skills becoming a foundation for more learning and innovation down the line. Now let's talk about this apprentice learning model. What's that all about?
This is key to Sterelny's argument. It's how he explains the connection between our learning environments and the cognitive adaptations we have for social learning. It's a really powerful way to learn complex stuff over a long time. Think about, traditional craft apprenticeships.
Okay, I get it. Like a blacksmith's apprentice.
You learn from a master over years. And Sterelny argues that a lot of forager societies work kind of like this.
Makes sense. So that's how people in those societies get so good at hunting, tracking, making tools, knowing all about their environment, even without formal schools.
Right. It's this consistent, reliable way to pass knowledge from the more experienced to the less experienced.
And what are the hallmarks of this apprentice learning model?
So first, you learn stuff that would be really hard to figure out on your own. Second, the learning process is structured in a way that benefits both the expert and the apprentice.
Right, makes sense.
And third, it's high fidelity, high bandwidth knowledge transfer. You're not just learning the steps, you're picking up on all the subtle stuff, the unspoken knowledge, the feel for it. And there's a lot of evidence for this model, especially in cultures without formal schooling.
He also talks about how adults set up these learning environments for kids, even without explicitly teaching.
Yeah. It's fascinating. They do it without realizing it sometimes. Giving kids access to tools, even simple ones, letting them play with materials. It encourages them to experiment, develop motor skills, learn by doing. They create this scaffolding for learning without even meaning to.
Now, even though this apprentice model is central, he doesn't completely dismiss teaching, right?
No, he acknowledges it. There's Lynn Wadley's work on Middle Stone Age technology, making composite tools with adhesives. Pretty complex stuff. Wadley suggests they probably needed some explicit instruction for that, maybe even language.
Interesting.
And Sterelny and Reed, they argue that a lot of manual skills just have to be shown. You can't just explain them. And Hewlett, his research with the Eka people, shows direct teaching too, like mothers teaching kids about edible plants. So it's not either. Apprentice learning is the framework, but teaching adds to it, especially for certain kinds of knowledge.
Now, how does all this help us understand those big paleoanthropology questions?
Yeah.
Like the whole behavioral modernity thing and the Neanderthal extinction.
That's where this model gets really interesting. By focusing on how we learn and share culture, it can shed light on these mysteries in human evolution.
Okay, so first, behavioral modernity. What's the puzzle there?
It's basically this. Homo sapiens, anatomically modern humans, showed up about 200,000 years ago. But those really complex behaviors, the stuff we associate with modern humans, art, symbolic expression, fancy tools, that stuff doesn't show up until much later, like 50,000 years ago. So what took so long?
Right, if we were biologically modern, why the delay?
The classic explanation is this sudden cognitive revolution, a genetic mutation maybe, or some big brain reorganization around 50,000 years ago that gave us a cognitive boost. But Sterelny, he challenges that.
Oh.
He points to McBrady and Brooks's work. They're finding more and more evidence that some of these modern behaviors actually popped up earlier. It wasn't just a sudden explosion.
So it was a more gradual process of becoming modern.
And the apprentice model fits that perfectly. It's not about a sudden jump in brain power. It's about these social learning mechanisms slowly getting better and our learning environments getting richer over a long, long time. Innovations would happen here and there, but they only really stuck if they could be passed on reliably.
And that's where population size and how connected groups are comes in.
Sterelny says that bigger, more interconnected populations are key to keeping cultural knowledge around. Imagine you have a small, isolated group. Someone with a special skill dies, or some knowledge gets lost, it's gone. But in a big network, that information is more likely to survive somewhere. Plus, bigger groups mean more diverse skills, which is good for everyone. Smaller groups, they're more fragile. This might explain why we see some innovations pop up and then vanish in the Middle Stone Age.
Okay, so bigger, more connected groups are better at keeping innovations alive. Now, what about Neanderthals? How does the apprentice model help us understand their extinction?
Sterelny's argument is that it wasn't just competition with Homo sapiens or environmental changes that did them in. It was also about how well they could learn and adapt culturally. And maybe, just maybe, they weren't as good at it as us.
So we were better at adapting to new situations, learning new things, because of our social learning abilities.
That's the idea. Homo sapiens, we had these bigger, more connected populations which helped preserve knowledge. And maybe our social learning was just a bit more efficient, more reliable, so when things changed, we could adapt faster, come up with new solutions. Neanderthals, maybe they just couldn't keep up.
It's a bit sad, but it makes sense. Now, Sterling talks about this human cooperation syndrome. What's that all about?
He's arguing that human uniqueness isn't just about our brains, it's about how much we cooperate.
Okay, yeah, we're pretty good at that compared to other animals.
Right. And this syndrome includes the information pooling we talked about, cooperative foraging, and this really interesting thing, cooperative reproduction.
Cooperative reproduction, what does that mean?
Basically, humans help each other raise kids way more than other primates. It's not just mom and dad, it's a whole network. Grandparents, older siblings, other relatives, it's like shared parenting.
I see. And the grandmother hypothesis is part of that, right?
Yeah.
Grandma's helping out.
Yeah, but Sterolny takes it further. He's talking about this whole support system, and it allows for that long childhood, the extended learning period. And then there's cooperative foraging.
Okay, how does that fit in?
This is how humans get food differently. It's about coordinating expertise and technology, multiple people working together. Think about a group hunting together or gathering food. Everyone brings their own skills to the table. It's not just finding food, it's doing it strategically as a team.
I see. So we're not just sharing knowledge, we're sharing the work of getting food.
Exactly. Now, there's been this debate about hunting. Is it mainly for food or is it like a show of strength, a way to signal fitness?
Right. Show off your skills.
Yeah. Sterolny, while acknowledging the signaling aspect, he leans towards provisioning being the main function. Hunting, especially big game, it provides a lot of food, reliably. That reduces risk, which is super important for a species with a long childhood like us.
Makes sense. But cooperation isn't always easy, right? There's always the risk of free riders, people who take advantage of the system.
Absolutely. That's a huge challenge for any cooperative system. Sterling talks about commitment mechanisms, ways to show you're in it for the long haul, to make it costly to cheat.
What are some examples of that?
There are internal mechanisms, like guilt or empathy. Those emotions keep us in line.
Right.
And there are external ones, public displays of commitment, like following group norms. Participating in risky activities like hunting, even things like initiation rituals or certain body modifications.
Oh, interesting. How do those work?
They act as markers of group affiliation. It makes
Yeah.
it costly to leave the group.
I see.
He also talks about Sperber's dilemma. This is about trust in communication. So imagine someone's telling you something important, but you can't check if it's true, like vital information about your environment. How do you know if they're being honest?
Right. That's tricky.
Sterolny says that teaching expertise is less susceptible to this because you're often watching someone do the thing. It's direct. But information about things that happened in the past or far away, that's where deception can sneak in. He thinks the way our social networks are structured, with lots of connections and cross-checking, helps reduce the risk.
So it's harder to lie when everyone's talking to everyone.
Kind of. And he brings up folk epistemology, our understanding of how we and others think and learn. He thinks this helps make cultural learning more reliable, especially when it comes to teaching and organizing learning environments. Like, adults implicitly understand what kids can learn and how to help them learn it. We've all got these intuitions about knowledge and learning, and they shape how we pass on culture.
Fascinating. So it's not just about the information itself, it's about our shared understanding of how minds work.
Sterling also delves into how we learn social norms and revisits this idea of group selection for cooperation.
Oh yeah, group selection. It's always a bit controversial.
Right. So on norms, he contrasts the view that we're born with a sense of morality with the idea that we learn norms through experience, seeing examples and being taught in social settings. He also emphasizes how important emotions are in shaping our moral judgments. On group selection, he acknowledges that punishing freeloaders can cost individuals. But he argues that the benefits of cooperation, like being able to choose good partners and build trust, outweigh the costs.
So cooperation is ultimately beneficial for individuals, even if it sometimes requires a bit of sacrifice.
That's the gist. And he's skeptical of the idea that our ancestors were constantly fighting wars with other groups. He thinks there were other factors driving human social evolution.
Okay, so to wrap up, what's the core message of the Evolved Apprentice? The one thing you want to leave us with?
Human uniqueness isn't about some special cognitive module. It's about this amazing interplay between how good we are at social learning and the environments we've built to make that learning even better. It's a gradual, cumulative process.
It's like we've bootstrapped our way to intelligence.
Exactly.
So it's not just our brains, it's our culture, our history, our entire way of life that makes us human. And what are some of the big implications of this? How should this change how we think about ourselves?
Well, it shows just how much culture matters. It's not just background noise, it's shaping us. And it highlights how dynamic human intelligence is. It's not static, it's constantly evolving.
This has been super insightful. For our listeners, I'll leave you with this. If our unique abilities are so tied to social learning and cooperation, how can we use that knowledge to tackle the challenges we face today? Our world's changing rapidly, and we're more interconnected than ever. Maybe thinking about how individual learning, cultural transmission, and the environments we create all interact can help us find solutions. Thanks for joining us on the Deep Dive.